It was in February 1944, at a place called Anzio, where there was a major Anglo-American battle. It was a bit of a bloodbath.
Lieutenant Marmaduke Hussey, caught behind enemy lines, makes a desperate attempt to leap over the German trenches.
Help! I fell down in front of a lot of Germans, about 2 yards away, and thought, shit, I've had it now. Halt! I was hit by a burst of Schmeiser, that's a sort of machine gun. I was not very badly wounded in the right hand, bullet through my leg, 2 bullets, and one which caused all the trouble in my spine.
Hussey was captured, and his right leg was amputated. He was then taken to Stalag 9B in Germany, a convent converted into a hospital for prisoners of war, including captured doctors. He was close to death.
There were 2 English doctors there, who don't know much about wounds anyway, because they're eye doctors. But they say he must have a blood transfusion. Immediately, he's dying. And no one had done a blood transfusion.
German camp doctors had no knowledge of transfusion. The operation was left to a medical orderly, following instructions from a book.
They just knew enough to get the right blood and pump it in. I'm very fortunate to be telling you that story 50 years later.
If Hussey had suffered his injuries early in the First World War, rather than at the end of the Second, he would have died.
Now, in the port city of Shenzhen, China, an institute called BGI is a key player in a project to discover what puts the super in superhybrid rice. And that means discovering the complex gene networks that control yield.
So we are in the process of deciphering genes that actually make this hybrid rice produce more.
With prodigious technological power, researchers in China have sequenced the 40,000 genes of the maternal and paternal strains that came together in superhybrid rice. But that's only the first step.
The project is not a simple sequencing project, so the biological contents has been expanding to reveal all the genes and to build network. All the genes are regulated.
And so the possibility occurred to me actually, that it would be very intriguing to use the holes that are already present in the brain to get to the brain without actually having to go through the skull.
Rodolfo Linares is really one of the giants in the field of neuroscience. I have friends that actually are neuroscientists, and when they heard that I was working with Rodolfo, they couldn't believe it. Actually, they said, "Wow, how is that possible?"
And the holes that I'm talking about are the holes produced by the fact that the brain has vessels, which basically bring oxygen to the brain, may be used as pathways into the brain.
Essentially, we are going to make wires that are smaller than the diameter of blood cells. And we're going to thread them up through the vascular system from a catheter that's been inserted in your leg all the way up into your brain, into the smallest capillaries, the smallest blood vessels there, where the electrodes can be very close to the nerve cells in your brain without requiring major surgery to open your skull up and shove the electrodes into the surface.
And if he can pull that off, then that's going to open up a tremendous wealth of knowledge about the brain and a tremendous ability to alter our brains in various ways. And that's incredibly exciting.
In the late 1800s, the top of the world was one of the last unexplored places left on Earth, and one of the most dangerous. Hundreds of Arctic explorers headed into the jumbled ice and were never heard from again. In 1881, Civil War hero Adolphus W. Greely led a scientific expedition to this fearsome place. He and his 24 men were set down on an isolated spit of land just 450 miles from the North Pole and left to fend for themselves. They endured months of pitch-black darkness and temperatures so cold the mercury in their thermometers froze.
28.4.
And when no relief ship returned, Greely led his men south in small open boats. Their diaries tell the story of men struggling to retain their humanity during a perilous journey through a frozen hell.
Most of us are out of our right minds. I fear for the future. Adolphus Greely.
It became the worst Arctic disaster in American history. Most of his men never returned alive. 121 years later, Greely's great-great-grandson returns to this haunted place to retrace his ancestors' horrific journey and determine for himself whether Adolphus Greely should be remembered as a hero or a villain. Little did he realize that one of his companions would barely survive the expedition.
Behind the walls of America's prisons, pharmaceutical companies finally found the ideal donor: reliable, compliant, and captive. They were available to donate plasma twice a week, 100 times a year in return for a few dollars or privileges. Prisoners also agreed to be vaccinated so that their plasma became resistant to disease and still more valuable.
Some of the companies have enlisted the help of prisoners, and they would give them injections of the vaccines and so forth, so that they would get a very high level of these antibodies. When this plasma was fractionated, it became one of the sources of enormously valuable product.
What the prisoners didn't know was that their disease-resistant plasma could generate profits of up to $100 a pint. By the middle of the 1970s, plasma had become one of the world's most precious fluids, per unit more valuable than oil or vintage wine.